In this video, we'll discuss two concepts, the statistical significance and the significance level. The significance level, it means the value of the alpha, or the type 1 error. The statistical significance, it means the p-value is smaller than 0.05. This is the definition of the p-value from our textbook. It means the p-value is the probability of the sample result, or the result from the sample, assuming that the null hypothesis is true. From this sentence, we don't really know what is the meaning of the null hypothesis, but if we know the meaning of the null hypothesis, what our understanding on the p-value should be the probability of the sample results. The result from the sample assume null hypothesis is correct, which means we should not reject it. Before we go to discuss the details of these two concepts, we will go back to the relationship between the population and the sample. Normally, we don't know the value, the parameters in the population. And what we know is we try to find the values from the sample to support, infer, or indicate our result regarding the population. Because in most cases, we don't really know the true value of the population. So we try to avoid the word of truth, proof, or certain in the real world. Because for the statistic, it is never 100% certain about something, and it always states its limitation explicitly, or it is clearly to tell the user of their research results where is the limitation of their analysis. And that limitation is the level of significance, or the type 1 error. What is the meaning of the type 1 error is we wrongly reject a true null hypothesis. For example, like we put some innocent people into the jail. That is the type 1 error. And the alpha equal to 10%, 5%, or 1%. It means there is a 10%, 5%, or 1% probability we make this kind of mistake. For example, like in here, we do a 2 tails hypothesis test, and we assume the mu equal to the mu 0. That is the null hypothesis. And the alternative hypothesis is mu does not equal to mu 0. So in this case, this is alpha divided by 2, and this 0.5%, this area is a reject area, and this area is a reject area. Which means if we calculate the value from this formula, and the value is in this part is larger than this alpha divided by 2, or smaller than this alpha divided by 2, we have to reject it. Based on the calculated z-value, we can find the p-value. And the p-value is the probability of the sample results, assuming that the null hypothesis is true. In this case, the null hypothesis is mu equal to mu 0. So when the p-value is smaller than 0.1, it means the probability should be in this part, in this area. And the area for the 1 is a probability smaller than 0.1. But in here, they don't tell you it is smaller than 0.005 or not. So we assume the p-value is in this area. And for the zone 2, or the area 2, that is the probability smaller than 0.05, which means this dot should be in this area. And of course, the p-value could be smaller than 0.01, or 0.0001, which means it will be something here or something here. If the p-value is in the reject area, for example, this is 2.5%, but if the p-value is bigger than 0.1, which means the p-value should be in this area. Because if this is a symmetric distribution, which means the p-value divided by 2 will be the upper bound or the lower bound of the p-value. If it is in the return area or do not reject area, we have to accept the HO. Actually, it should be the do not reject, the null hypothesis. If the p-value is smaller than 0.05, it means this dot lines should be in this part, which means it is in the reject area. So we have to reject the null hypothesis, and then we will accept the alternative hypothesis. And we give a definition for the p-value smaller than 0.05. When the p-value is smaller than 0.05, it could be 0.04, or it could be 0.001, or it could be 0.000001. For this case, we call it is a statistical significance. Actually, if the p-value is just smaller than 0.05, but it is bigger than 0.01, we call them the fair statistical significance. If the p-value is smaller than 0.001, we call it is an excellent statistical significance. So what is the meaning for the p-value is in this area? If the p-value equal to the 10%, which means on each side, they will cover the 5% of the distribution. And from this graph, what we can learn is that there is a very high probability for something happened. So which means very probably the sample mean will be equal to the mu 0. So for the mu equal to the mu 0, that is the formula to calculate the calculated z value. So we use the x bar, this is from the sample, minus mu 0 divided by the standard deviation. So which means this is in this area, and there is a very high probability for them to equal to each other. So which means the sample is not significantly different to the population. And if the x bar minus mu 0, they give you a value is very far from the center of this distribution. So of course we will see the sample is very different to the population, or the mu is very different to the mu 0.